Why do animals have such different lifespans? Aging is one of the few experiences shared across nearly all living organisms, but animals across the animal kingdom have vastly different timelines on how quickly or slowly aging actually occurs. Why does a tiny worm live just a few weeks while a whale can see 2 centuries? Why do some cold-dwelling species seem to defy time itself, and how have humans managed to nearly double their own lifespans over the last century? The labworm C. elegans experiences life in mere weeks, while most tortoise species live well over 80 years. Nature is full of vast biological differences in how aging unfolds across species. Mice and rats have short 4-year lifespans, while bowhead whales can live past 200. Aging seems to be a universal biological process, but its timeline varies dramatically depending on the species in question and its biological context. Aging is more than simply growing frail and weak. It's the biological process where cells begin to deteriorate and die, gradually reducing the efficiency of bodily systems and leading to eventual physical decline. Cellular decay. The root of aging lies in cellular dysfunction and death. Young organisms constantly regenerate cells, but over time this regeneration slows, which weakens the body's overall functionality and resilience. When we're young, the cellular repair in our bodies is rapid and efficient. Dying cells are quickly replaced, keeping the body strong. But as we age, this ability falters and eventually leads to the gradual breakdown of systems. With age, the body's cells lose their functional sharpness. They underperform compared to their youthful counterparts, and this sets the stage for age-related diseases and a natural progression toward death. Given aging's universal nature, it seems puzzling that some animals live decades while others only survive for weeks. But this mystery is solved by looking at the evolutionary pressures that each species faces. Environment plays a crucial role in shaping how long animals live. Conditions like climate and habitat introduce pressures that mold the evolution of aging and lifespan across different organisms. Generally speaking, larger animals tend to live longer lives. Their physical size often gives them a survival advantage and also allows for a slower pace of life and extended reproductive opportunities. In the icy waters of the Atlantic and Arctic, creatures like the Greenland shark and Arctic clam thrive for centuries. This is aided by a frigid environment that slows their metabolic and aging processes. Among the most extraordinary examples of longevity is the Antarctic glass sponge, a deep-sea inhabitant capable of surviving more than 10,000 years in its cold and stable underwater habitat. In frigid climates, animals' heartbeats and metabolisms decrease. This slow-motion existence likely delays aging and suggests that environmental chill can function as a natural life-extending force. Although it isn't a hard rule, large animals like whales and elephants generally outlive smaller ones like mice or worms. Their size contributes to slower growth and longer reproductive windows. On the other hand, smaller dogs tend to live longer than bigger dogs. Puppies. Small organisms such as flies and worms have bodies filled with cells that can't easily divide or regenerate. Once damaged, these cells stay that way, which causes rapid aging and shorter lifespans. The risk that comes with predation shapes how animals evolve. Small prey like mice live fast, grow quickly, and reproduce early. Large creatures face fewer predators, and this gives them more time to develop and reproduce. This reduced external threat allows their bodies to invest more in long-term survival than rapid procreation. Bats, birds, moles, and turtles buck the trend by living longer despite being small. Their secret lies in unique adaptations like flight or burrowing that help them avoid predators and live longer. Animals of similar size or habitat can still age at wildly different rates. These inconsistencies often come from differences at the genetic level, which influences how cells respond to internal and external stress. Even with matching environments and sizes, species may age differently due to genetic variances. The way their cells handle damage or threats plays a large role in defining their biological lifespan. Ultimately, it's not just one factor but rather a mix of body size, environmental conditions, and genetic coding that decides how fast an animal ages and how long it might live in its natural setting. Humans average about 73 years of life today, placing us mid-range in the animal kingdom. While we're not the longest lived, we've certainly shown a unique ability to stretch our lifespan over time. In the early 1900s, humans averaged just 50 years of life. But through technological, medical, and social advancements, we've added decades to our lifespans in just over 100 years. Humans stand apart in the animal kingdom as possibly the only species capable of consciously adapting to extend life. By addressing environmental threats and improving nutrition, we've reshaped our own biological destiny. Better access to nutritious food has also allowed humans to grow stronger and live longer. Proper diet helps delay age-related diseases and supports the body's regenerative capabilities well into old age. Unlike wild animals, humans have learned to manipulate their environment to minimize exposure to dangers and harsh conditions, which has significantly increased both our lifespan and quality of life. Medical science. Advances in healthcare have enabled early diagnosis and treatment of age-related illnesses, contributing greatly to the increased average lifespan that modern human societies now enjoy. The gift of public health. Sanitation, vaccines, and public health policies have reduced early life mortality and prolonged adult health. This has created a new human reality where aging does not necessarily mean suffering. We've made incredible strides in understanding why we age and how to live longer. But much of aging's complexity remains unexplored. When scientists study aging across species, they understand much more about survival, adaptation, and how time shapes the value of life itself. We've made incredible strides in understanding why we age and how to live longer. We've made incredible strides in understanding why we age and how to live longer.